Hey students, you are most welcome here in PACE Academy. As you know, we are doing atomic structure chapter. In our previous lessons, we have discussed about the introduction of atom, importance of the atomic structure, and about the subatomic particles. Now today we are focusing on atomic models. See, first in atomic models we will be talking about the Thomson's atomic model. You know, this is the very basic model related to the structure of the atom, but before Thomson also some efforts were done to understand the structure of the atom. See, it was Sir J.J. Thomson and Rutherford who studied first about the structure of the atom. You know, for this all efforts, Thomson's received Nobel Prize for the theoretical and experimental investigation on the conduction of electric current by gases, as we have done yesterday in cathode ray discharge tube experiment, which was performed by Sir J.J. Thomson. As I told you yesterday in previous lesson, that usually gases do not conduct electricity, but if we provide certain special conditions, then gases can also conduct electricity. Now see, according to J.J. Thomson atomic model, atom is spherical in shape. Atom is spherical in shape. Atom is round in shape, like as a ball. And the radius of the atom is approximately 10 to the power minus 10 meter. That is equal to 1 angstrom. So this is the point which was obtained there in this atomic model, that the radius of the atom is 10 to the power minus 10 meter around. And positive charges are uniformly distributed there throughout the atom, throughout the sphere, throughout the ball. See, first point, what I said, the radius of the atom is 10 to the power minus 10 meter or 1 angstrom. This is first observation. And what the second observation of this atomic model is, that throughout the atom, throughout the sphere, throughout the ball, plus and minus charges are uniformly distributed. What does it mean? It means atom is neutral. So one radius of the atom is 10 to the power minus 10 meter or 1 angstrom approximately, and second conclusion from this atomic model you can draw is that atom is neutral. That means the number of electrons and protons, that means the number of positive charges and negative charges there in an atom is always same, is always equal. So the net charge on the atom will be neutral. Electrons are arranged in such a manner to give most stable electronic arrangement there in an atom. This is what we were talking about, that C plus minus plus minus plus minus plus minus. So electrons and protons, that is positive charge and negative charge, both are uniformly distributed there in this spherical atom, there in this ball shaped atom. This was J.J. Thomson's atomic model. This J.J. Thomson's atomic model is also known as plum pudding model, raisin pudding model, or watermelon model. As in watermelon, seeds are uniformly distributed throughout the watermelon. As in pudding, raisins are uniformly distributed there in that pudding, like that. In atom also, electrons and protons are uniformly distributed throughout the sphere, throughout the atom. This is what Sir J.J. Thomson's atomic model was. So these are the different names given to Sir J.J. Thomson's atomic model. Now see, this Thomson's atomic model, you can visualize it as a pudding or watermelon of positive charge with plums or seeds, that is electrons, they are embedded in it. Now see, the mass of the atom, according to J.J. Thomson's atomic model, mass of the atom is distributed uniformly throughout the atom, because you know electrons are almost massless. So whatever mass an atom is having, that is because of protons, and since protons are uniformly distributed throughout the atom, so the mass of the atom is also uniformly distributed throughout the atom. So as I have already told you, that these two conclusions we can draw from this Thomson's atomic model, that one, the radius of the atom is 10 to the power minus 10 meter order, and atom is always electrically neutral, is always chargeless. Now these were the postulates of Thomson's atomic model. Now what were the drawbacks of Thomson's atomic model? This we will do here in this topic. This Thomson's atomic model was unable to explain the stability of the atom based on the experimental results. Why atoms are stable? This Thomson's atomic model was unable to explain. This Thomson's atomic model was unable to explain photoelectric effect and thermoionic emission also. This Thomson's atomic model was unable to explain alpha particle scattering experiment by heavy atoms, by higher elements, by atoms having higher atomic mass. It could not be explained. So these were the main drawbacks of Thomson's atomic model, and because of these drawbacks, there was need of some better atomic model which could explain the structure of atom in a much correct way, much better way. So but before going to the next Rutherford's atomic model, radioactivity also should be discussed so that we can understand Rutherford's atomic model properly. So next is radioactivity and observations of Rutherford's. See, as yesterday we stated that X-rays are obtained by the secondary effect of alpha rays. Cathode rays. When cathode rays strikes on an anticathodic material, then X-rays are produced. Since these X-rays are having very high penetrating power, so are used for the study of interior structure of atom or matter. You know, in medical science also, these X-rays are used to study the fracture of bones there in human beings. X-rays are not deflected by electric and magnetic field. What does it mean? Means X-rays are not made of charged particles. Since X-rays are not made of charged particles, so will not be affected by or deflected by or deviated by electric and magnetic fields. Now see, X-rays are having very high energy radiations, and since X-rays are having very high energy radiations, so can cause ionization of the gases. This ionization, as I told you yesterday also, that if X-rays of your some sensitive body parts will be done again and again, then the ionization of that body part will be taking place, and that ionization further will be responsible for causing cancer there in our body. So that is why elders always advise us not to use it frequently, not to do it frequently.